Hello, and welcome to this Radware webinar. My name is Eyal Arazi, and I'm a Product Marketing Manager here at Radware. In this webinar, we invite you to come hack with us. We're going to go through, in detail, the anatomy of not one, but two cloud-native data breaches. We're going to go through the step-by-step evolution of how these data breaches evolved. We'll talk about how the companies were exposed to begin with. We'll talk about what the hackers did once they penetrated the network. And of course, we will also discuss the lessons to be learned from each of these incidents and what could have been done differently that might have prevented these attacks. The webinar today has a number of parts to it. So for the first part, we'll talk about the security challenges in the public cloud. This will be a brief, high-level discussion of some of the challenges created by adoption of public cloud technologies and migration of computing workloads to the public cloud. Next, we will examine a social media application and how it was breached. And we will do, as we said, a step-by-step discussion of exactly how it was penetrated, how the hackers moved within the network, and how ultimately they leaked data. Then, in the third part, we will look at another data breach, this time from an identity management service. But instead of going in detail into each and every step, we will simulate this data breach within Radware's Cloud Workload Protection Service product, and we will see how this would have looked like from our side. Based on that, we will see some of the telltale signs of a data breach and how possibly it could have been stopped in time. Then, in the fourth part, we will do a brief summary of some of the lessons learned and what can be done next. So let's begin. So as we've said, the first part is an overview discussion of some of the security challenges of migrating computing workloads to the public cloud. So if you're attending this webinar, you probably don't need to be told that migration of computing workloads to the public cloud is a major industry trend. There is a quote there you see on the top of the screen that from Forbes in 2018 that by 2020, over 80% of enterprise workloads are expected to be running in the cloud. Now, we can obviously debate whether that figure should be higher or lower, but in any case, we can see that this is a major industry trend that is affecting almost everyone and every company out there. Now, some of the key drivers that drive this migration is, of course, first and foremost, cost, with regards to companies being able to consume services elastically and expand or contract depending on their needs instead of having to make upfront capital investments. But another driver, of course, is the agility and flexibility that the cloud provides. As we had mentioned, companies can spin up services, spin down services, expand their network, put new resources on the cloud, take them off, and so on, with far more agility than running on their own physical premise. However, it should be realized that this agility and flexibility also comes at a cost. And that cost is lower control and lower visibility, which ultimately affects the security of the cloud environment. We'll talk about that in just a moment. Now, of course, when we talk about a world of clouds, first and foremost, we talk about Amazon Web Services, AWS, which currently controls about 50% of the market or more, followed by Microsoft Azure and Google Cloud Platform. And then there are a host of smaller and or regional players, such, for example, as Oracle Cloud, IBM Cloud, Tencent and Alibaba in the Asia-Pacific region, and so on. So let's discuss what are some of these security challenges that we mentioned and why do they affect companies migrating their workloads to the cloud. So it should be realized, first and foremost, that once you're running your workloads in the cloud, then security becomes a shared responsibility. And this is actually defined in an industry term called the shared responsibility model. And what it basically means is that security of workloads running in the cloud is split between the cloud provider themselves and the customers who own those resources. An easy way to look at it is that the public cloud providers are responsible for security of the cloud. That is their own core infrastructure and their own core equipment and services that they provide. So examples of that would be the bare bone metals themselves, computing infrastructure, networking, storage, hypervisors, virtualization, and so on. Now, the customer, on the other hand, is responsible for the security of the workloads in the cloud that are running on top of the public cloud infrastructure. So that includes the applications themselves, customer data, the runtime environment, any middleware servers and services, the operating system, and so on. However, one of the key problems when it comes to security of cloud-hosted assets is that the insider of the old physical premise-based world is now an outsider in the world of the cloud. So what do we mean by that? So let's look at and contrast between the world of physical computing and the new world of cloud computing. So when you look at the old world of the on-prem data center, which, let's face it, wasn't that long ago, usually had IT staff and administrators residing within the same location or, at worst, within the same network as the computing resources they were responsible for. So there they had a very high degree of visibility and control into those assets. They protected them against insider threats. And security was mostly concentrated on perimeter protection against external threats. So using mechanisms, for example, such as firewall, secure web gateway, anti-DDoS, WAF, and so on and so forth. Now, as we said, in this environment, administrators had a very high level of control over their resources, and if they ever had a problem, if they ever had identified a breach, for example, the worst case scenario, they could walk over to their assets, to their server or their database or whatever, pull out the plug, and contain the breach that way, at least as a first step. However, when you migrate your resources to the cloud, you lose a lot of that control. So let's look at that. So when you look at the world of the public cloud, you see that basically, essentially, everything is now hosted on the outside. The computing resources are no longer running in the same location or in the same network as the people running them, as the IT staff, developers, and so on. And everything is now running off in the cloud somewhere they don't know exactly where. And all the access they have to it is remote. And this is all done using remote access protocols, standard APIs. Everything is publicly documented. And you could say that really IT staff have become an outsider to their own services. Now, in this world where they are outsiders, IT staff and malicious users or hackers have essentially the same level of access to these workloads running in the cloud. As we said, it's all done using standard connection protocols. Everything is publicly documented. Everything is exposed. So in this environment, it emerges that the security perimeter of cloud-hosted resources is no longer defined by where they're located or by what defenses they have surrounding them, what perimeter protections, but rather what are the permissions that users have to access them. And this is what distinguishes between IT staff who have legitimate access and hackers who should be prevented from that access. So let's look a little bit at that. So if we say that the security perimeter is defined by the access permissions to cloud-hosted resources, it follows that your permissions equal your attack surface. Now, we talked earlier about how one of the main drivers of migrating to the cloud is the agility and flexibility that cloud environments allow. However, as we said, this comes at a cost. Now, it's also a problem specifically with permissions because the cloud environment makes it very easy to grant users excessive permissions and kind of difficult to keep track of them. In the name of expediency and increasing the speed of business and increasing go-to-market time, or decreasing go-to-market time rather, extensive permissions are frequently granted to users, whether they should have them or not. And what emerges is that in fact many users never use most of their permissions. Now in the long run, this creates a major security vulnerability because should any one of those users with excessive permissions ever become compromised by hackers, these excessive permissions and these promiscuous permissions can be exploited by hackers in order to expand within the network and steal data. This is why we say that excessive permissions are the #1 threat to public cloud environments, and that containing those permissions should be the top priority for security administrators. Now, one of the problems with regards to curtailing excessive permissions is that in many cases, excessive permissions are mischaracterized as misconfigurations. But when you actually drill down into the root cause of a data breach, you see that it actually stemmed from permission misuse or abuse. So let's see how this played out in this particular case of a social media application. So for case study number 1, we're looking at a social media application. Now, this social media application, like many other social media apps and networks, is a born-in-the-cloud organization, meaning they are running their workloads in the public cloud, in this case on AWS, since day one. This social media application has over 20 million users, storing over 1 petabyte of user data, again on top of Amazon Web Services. So we can see it's quite a large amount of users and a large amount of customer data. In 2018, this company was a victim of a data breach incident in which hackers stole their main customer database, exposing over 20 million user records. So let's take a step-by-step look at how it happened. So the first step in this data breach is something that frequently happens of compromising a legitimate user. Now, user credentials can leak in a host of ways. It can be a spear phishing incident, it can be negligence, it can be some sort of misconfiguration, it can be theft of third-party credentials, and so on. But in most data breaches that we see, indeed, the first step is theft of the access credentials of a legitimate user. In this particular case, it was a targeted spear phishing attack, which targeted one of the cloud account system administrators of this organization, through which hackers were able to steal their access password. Now, as we've mentioned, this is just one example of an attack, this spear phishing incident. However, there are many other ways in which credentials can leak. So it follows from that you should always assume that your credentials might already be compromised. So if that is the case, what you should be thinking about is not just how I could protect my access credentials. I mean, you should protect them, but beyond that, you should be thinking, how would I limit the damage should they ever become exposed? So let's look at what hackers did with those credentials once they had them. So once the attackers had their access credentials, once they obtained a user password to the cloud environment, they went in and fortified their own access. So what they did is they went in using the username and password they compromised, and using existing permissions of that user, created a new set of API access keys through which they could access the cloud environment directly. Now, this is a very abnormal type of activity, and yet it went unnoticed by the company, who didn't know that there is a new set of API keys out there that they have no idea about. The next step that attackers went through is reconnaissance. Now, this is, again, a very frequent step during cloud-native data breaches, that once attackers gain a foothold within the network, and once they fortify their access, they start to understand the lay of the land, so to speak. They launch many internal port scans to try and find open hosts. They run many queries to try and enumerate their own access permissions. They query security policies to see what access they have into which resources, and so on. Now, this step of reconnaissance is actually a very telling sign, in many cases, of a data breach incident, because legitimate users don't really need to do any of that. They should already know what access credentials they have, and they don't need to map out the internal network. So this is usually a highly indicative step for a data breach. However, not only did this highly indicative step go unnoticed by the company, but what hackers found out in this particular case is that their stolen credentials had quite extensive AWS permissions, which allowed them to do very serious damage. So what did they do next? So once hackers had gained a foothold within the network, and once they had fortified their access to the cloud environment, the next thing they did was to begin what is called lateral movement. That is, moving from within the network into production resources in order to look for high-value customer data and other sensitive data. So in this particular case, hackers went into the production user database and created their own private snapshot. They essentially replicated the master user database and were in possession of their own private copy of the master database within the company's cloud network. Now again, this highly abnormal activity went unnoticed. Now once they had created their own private copy of the database, the attackers tried to launch the database snapshot. However, because of the size of this database, as we had mentioned, it stored over 1 petabyte of user data. This action took a very, very long time. So after about 30 minutes, attackers terminated it. We don't know why, whether either they were pressed for time or possibly they got stressed. Instead, they went into the master database and changed the master password. So once they had decided to discontinue their effort of launching their own snapshot they had created, the attackers just went into the system settings of the production user database and changed the master database password. As a result, they were effectively in control of the company's user database. Now, this is the first time that the company even took notice that they even had a problem to begin with. Once attackers had changed the password, it broke a number of internal processes such as health checks, data commits, user access, and so on. And only then the company started to try and figure out what was going on and realized that they had an intruder in their network. Once the company realized that they had an intruder inside their network, they began going about to try and block off their access. However, since all of these resources were running far away in the cloud over AWS, the company didn't have the direct control to go in and just shut down the resource. Instead, they had to go through AWS customer support in order to get access back to their own resources and reset the passwords to their master database. This process took over 2 hours, during which time the horses were out of the barn, so to speak, and the data had been extracted and stolen by the hackers. The result? Over 20 million customer records exposed, and the company had to go about and notify all of their customers and all of their social media users that their data has been compromised. So let's, just for review, look at the attack kill chain. So looking at the attack kill chain, we can see kind of the step-by-step evolution of how this attack evolved. So it began, first of all, with an AWS spear phishing attack targeted at one of the network administrators of the cloud environment, followed by fortification of access by creating an independent set of API access keys which hackers then used. Next, they started going about and doing reconnaissance in the network, launching scans and queries to enumerate their permissions, followed next by lateral movement and expansion into production resources, first by taking a snapshot of the production database, then trying to launch it, and finally taking hold of the database itself by resetting the master passwords to the production database. Finally, the data acquisition and data extraction step itself of logging into the database and extracting all the relevant data they could put their hands on. So as a result, over 20 million customer records which were exposed just in this incident. So let's look at the lessons learned from this incident. So first and foremost, you should assume your credentials are already compromised. As we had talked about earlier in this presentation, credentials can leak in a multitude of different ways. You can go on the darknet and buy AWS access credentials in bulk. They can leak through targeted spear phishing attacks, negligence, misconfiguration, third parties, and so on. So once you start by assuming that your credentials, or some of them, are compromised or may be compromised, then the question then becomes not only how do I protect those credentials, which of course you should do, but rather what do I do once they become compromised and how do I limit the damage? So that's number one. The second lesson to be learned from this data breach of a social media application is that most users have too many permissions. If we look back at the attack kill chain and think of some of the steps that hackers went through during this attack, they created their own set of admin level API access keys. They launched reconnaissance scans within the network. They went into the production database and created a snapshot. They tried bringing up and exposing to the world the snapshot, and then they went in and reset the password to the master database. These steps are both highly indicative of data breaches, but they also require quite far-reaching permissions, and it's very likely that the user didn't need all those permissions to begin with. Had those permissions been limited to begin from the start to only what that user needed for their day-to-day job, then attackers would have had a much more difficult time and possibly would not have been able at all to do everything that they went through in this example. So that's lesson learned number two, that most users have too many permissions. The third lesson learned from this case is that early detection is critical. Because again, let's look at some of the steps that hackers went through of, again, as we said, creating their own set of administrator-level API access keys, reconnaissance scans, creating a database snapshot, launching it, and so on. a lot of these steps are highly indicative and highly abnormal steps and highly indicative of data breach activity and data theft attempts. Had the company had the tools and processes in place to identify and alert against those activities, then possibly it could have stopped any of these activities as they were unfolding and before that hackers had breached their master database and stolen all of their customer data. So we say again, early detection is critical, and you need the right tools in place to identify those excessive permissions, but also monitor user activity within the cloud account and alert on it. So let's take a look at a second data breach now. Except for in this data breach, we're not only going to go through the step-by-step process of how it unfolded and the attack kill chain, but what we did with this example is that we simulated it within Radware's own cloud workload protection service to see how it would have looked like from the other side and whether our system would have caught it. So we'll start by going in brief over how this attack unfolded. We'll do it pretty quickly, and then we'll go through a step-by-step detection and alerting process of how it would have looked in Radware service. So let's look at the identity management service, which was the target of data breach number 2. So this example is on a cloud-based identity and access manager service provider, sort of a one-stop shop, single sign-on provider for various services, which serves a clientele of large-scale enterprise-grade customers with over 2,000 such customers, also running on top of AWS and storing large quantities of customer data. In the slide in front of you, you can see the step-by-step progression of the attack kill chain in this case of this data breach. So very similar to the first case study that we analyzed just a few slides ago, we see that hackers in this case as well went through a series of steps, first to gain access to the network, then to expand within it and escalate their privileges, and finally to acquire data and to extract it. So in the first step, similar to the previous case we examined, the company was the victim of a spear phishing attack in which access credentials to their network were stolen. However, it's important to point out that in this case, the target of the spear phishing attack wasn't the company itself, but rather one of their third-party partners who happened to have access credentials to their network. So once that third party was attacked and affected, the company was exposed, even though it wasn't them who was attacked. So in the next step, step 2, attackers gained access permissions into the company's network and leveraged the access credentials and the API access keys that they stole in order to access and log into the company's cloud environment. In step 3, they started doing reconnaissance. Again, very similar to what we saw in the previous step, where they started listening on all instances, mapping out security policies, and enumerating their own permissions in order to try and understand what access permissions they had and to which resources. Then in step 4, they began lateral expansion by launching a new instance with a privileged role using the access credentials that they had and the permissions that they had. And from that instance on step 5, they began running a series of port scans within the cloud environment in order to look for available web servers that they might have access to. Now, in the world of online hacking, web servers are frequently regarded as highly valuable resources because in many cases they can communicate both internally with internal resources, such, for example, as databases or other servers, as well as communicate outside, externally, to the world. So they're considered in many cases the holy grail of an attack, and for a hacker to acquire and achieve access to such a resource is one of their main objectives. So once they ran step 5, port scans to find an available web server, in step 6, the attackers identified a vulnerable web server running an unpatched version of Apache, which they then used to run an exploit targeting that specific version. Doing that, they were able to take over the server and gain root access to it, and from there they connected to the internal customer database of the company, which they then copied and extracted into the world. So as we can see here the step-by-step evolution of the attack, starting with acquisition of credentials, fortification of access, then reconnaissance, lateral movement and privilege escalation, and finally data acquisition and exfiltration. However, in this case, we're not going to leave it just in a description of how it happened, but at Radware, we also went back and simulated this attack on our own servers and within our own cloud protection product of Cloud Workload Protection Service. So what I'm going to show in the next series of slides are screen captures from within Radware's Cloud Workload Protection Service product, which protects public cloud environments. And we can see that by simulating the hacker activity, how this would have been identified by our own service. So in the screenshot in front of you, you can literally see the step-by-step attack kill chain that Cloud Workload Protection Service creates. So in this webinar, I'm going to show just screenshots due to the technical limitations of the webinar format. However, this is an interactive screen, and we can go through each and every step separately. So let's look at how going through each step would look for a user of Radware Cloud Workload Protection Service. So as we'd pointed out, the first step in this data breach was for attackers to go into the network, into the cloud environment, create a role for themselves, a new user for themselves, and start by enumerating the access permissions that they have and see what access they have. Now, looking at Radware's product, you can see that this step involves a number of anomalous activities, including, for example, first-time usage by certain API calls, which the user had never used before, as well as non-typical AWS API calls, which were flagged as suspicious. Now, such an activity on a day-to-day basis may or may not be legitimate user activity. However, what our system does is that it also correlates individual events and puts them into overall context. So the system had flagged this activity as anomalous, but as it started to detect additional activities that connected to it, it started putting them together into a puzzle or an attack story of the full data breach attempt. So let's look at how it looked next. The next step after attackers logged into the system and created their own user was to launch a new S3 bucket and make it publicly accessible and execute on their access permissions. So here we can see that this would have been flagged by the network, by the system as well, because it involves taking sensitive data and making it publicly exposed. The next step for hackers was to spin up their own instance running from within the company's cloud environment in order to leverage that for system scans. So this activity was flagged as well by Cloud Workload Protection Service. Now, we'll see in the next series of steps that these steps that were flagged and these activities pertain mostly to the instance that the attackers had spun up. So let's look at how it would have looked like. So clicking on the next step in the attack progression, we can see that Cloud Workload Protection Service identified the port scanning activity. As we had said, port scanning is frequently a highly indicative measure of potential data breach. And in this case, we can see how it was flagged. The next step for hackers, after they ran their internal port scans, was to identify a potentially vulnerable web server within the company's cloud environment and to try and access it. So we can see here again that the system identified this new communication channel and flagged it as potentially suspicious. Now, by this point, we're already starting to have quite a lot of data, and for Radware Cloud Workload Protection Service to correlate quite a number of activities which slowly start building into what a data breach looks like. So moving on ahead, once the attackers had established a new communication channel with their target server, they went in and began communicating with it in order to deploy an exploit kit to gain root access to the server. In this particular case, it was an Apache-based server running Tomcat, Java's application server running for Apache, and the attackers invoked a call called wget, which is a call to fetch web resources in order to download an exploit kit for that specific server and that version, which they found not to be patched, and ran it on the server, thereby activating the exploit and gaining root access to this web server. So after hackers communicated with the web server and downloaded an exploit toolkit to it, they then executed on it, ran it, which would have been flagged by Radware Cloud Workload Protection Service as well as a first encounter with a new process that it identified as suspicious. Finally, once they had taken hold of the web server with two-way communications both to other internal company resources as well as the outside world, attackers logged into the database and started communicating outside when they copied the data from the database. Again, this would have been flagged as an anomalous outbound communication by Radware Cloud Workload Protection Service. So we can see, to summarize, that like the first case study that we analyzed earlier, this attack also went through a structured series of steps through which the attack progression evolved, starting with a spear phishing attack to grab access credentials to the network, followed by reconnaissance and lateral movement of figuring out what access permissions they had, and then launching their own privileged instance from which they could operate, then continuing reconnaissance by launching port scans within the cloud environment to find vulnerable web services, and then accessing those web services, exploiting them, downloading attack tools onto them, and gaining a foothold in order to access sensitive data on the database and then exfiltrate it. Now, had Radware Cloud Workload Protection Service been running there, it could have detected all of these steps and flagged them. As we had seen in this illustration, the attack was detected by correlating multiple anomalous events within the AWS Cloud account, and automated response mechanisms would have been able to prevent the data breach before it culminated in the connection to the database and theft of data. So before we wrap up, let's do a brief summary of what we learned through this examination of 2 case studies of data breaches of cloud-native companies and cloud environments. So the first one is that there are a number of recurring hallmarks to cloud-native data breaches. We saw a number of recurring themes and recurring steps in both cases, starting with theft of credentials, which could be either from the company or from a third party or other ways as well, followed by access to their network, reconnaissance to try and figure out what permissions the compromised user has, privilege escalation where required in order to try and attain a higher level of access privileges, followed by lateral movement into sensitive production resources, followed by data acquisition of sensitive customer data, and realized finally by data extraction of stealing the actual data itself. Secondly, what we can learn is that there are a number of common conclusions from these attacks. The first one is that you should always assume that your credentials are already compromised. We had seen in both cases that access credentials got stolen in different ways. One was stolen directly from the company, the other was stolen from a third-party partner. And yet, in addition, there can be a multitude of different ways through which access credentials can be stolen, either by malicious intent or through negligence, misconfiguration, and so on. But if there are so many ways that these credentials can leak, then you should assume that they might leak and that your credentials, or some of them at least, might already be compromised. So if that is the case, you should think about how to limit the damage. And that brings us to our second conclusion of most users have too many permissions. And we saw this as a recurring theme in both cases where the users who were compromised had very extensive permissions, which allowed hackers to do quite a lot of activities within the network, creating new roles, spinning new instances, expanding to production resources, and finally stealing the data. So in reality, most users never use most of their permissions, and a smart hardening approach will look at the gap between defined permissions and use permissions in order to eliminate unnecessary and excessive permissions. The last conclusion to be drawn from both of these case studies is that early detection is critical. And again, even if we assume that the users did indeed need all of the access credentials that were exploited in these cases, an early detection system would have been able to identify and flag this suspicious activity and identify it indeed as malicious activity. We had seen that in both cases, the lack of such systems allowed the data breach attempt to culminate and to reach the conclusion of theft of data. But we saw in the second case study how a detection system such as Radware's Cloud Workload Protection Service would have been able to identify these thefts and flag them hopefully in time. So Radware provides a dedicated service to protection of cloud-native infrastructure. Radware's Cloud Workload Protection Service is a cloud-native solution for comprehensive protection of your public cloud assets. It has a number of key features and benefits to customers. First and foremost, it provides comprehensive protection by protecting both the overall cloud security posture of the cloud account as a whole, as well as granular protection for individual workloads. So it protects both the high level and sort of the low level of resources running in the cloud. Secondly, it is an agentless cloud-native solution. So there's no hardware or software to be installed, and it allows for very easy and low-touch deployment. Next, we have the two key features that really are the hallmarks of Radware's technology. So first of all is our approach to smart hardening, which indeed looks at the gap between defined permissions or granted permissions and used permissions. That is, the gap between what the user is allowed to do and what the user actually does. And then it flags up unused permissions, which the user in most likely does not need, and provides security administrators with smart hardening recommendations to eliminate excessive permissions and reduce their attack surface. The second key technology feature that we have is a detection engine based on artificial intelligence and machine learning algorithms. So even if hackers are somehow able to penetrate the network and leverage existing permissions, this detection engine will look for malicious behavior indicators, or MBIs, and alert on potentially suspicious activities happening within the cloud account. However, it will not just alert on them, but will also correlate individual events and create streamlined attack storylines, as we had seen in the second example of how it would have looked like in Radware's network, or in Radware's system rather. And it also allows for both manual and automated response mechanisms to block certain activities once they cross a certain threshold of risk. So if you found the information presented in this webinar as pertinent and relevant, we encourage you first and foremost to assess your own needs and vulnerabilities. Look at your own network, look at what are the resources running in your cloud environment, and ask yourself, do you have the right tools and processes to alert you on users who have too many permissions and users who are abusing their permissions in their cloud environment. If you think that you can improve in that arena, then we certainly encourage you to reach out and do an online demo, a free online demo of our product, of Radware Cloud Workload Protection Service, and then possibly even do a full proof of concept trial in your cloud environment. So thank you so much for attending this Radware webinar on Cloud Workload Protection Service. We hope you enjoyed the content and found them interesting, and we invite you to connect with us through our website, www.radware.com, or by social media through our LinkedIn, Twitter, or YouTube accounts. Thank you, everyone, and have a great day.